If I turn this switch on my rate meter, an LED turns on and it blinks for every detection. This is actually a modification I made, and in this video I'll show you how I did it, and it's not very complicated. So this is the inside of the rate meter, and you can sort of see the modification here. It consists of these black wires on this upper circuit board. The modification itself is relatively simple. I cut the trace that goes to the speaker and then routed it through a switch, and that switch has two positions, so it's basically turn the speaker on or turn the LED on, depending on which position the switch is in. And the switch is actually one of the switches on the front. It had a few positions that were unused, so I just reused that switch and it worked out pretty okay actually. In case you happen to have the same rate meter, I measured the voltage the speaker is driven at, and it turned out to be about 10.5 volts, which meant that in order to use the LED I was using, I needed a 380 ohm resistor in series with the LED. Now of course you could use any LED for this modification, but I used these panel mounted LEDs. There's like a ring of metal around the LED itself that sort of protects it, and it also looks pretty good, and it's easy to mount to the front panel as well. I also measured the voltage at which the speaker of my LED Model 2 rate meter is driven at, and it turned out to be actually 45 volts, so you would need a larger resistor if you made the same LED modification with this rate meter. And just as a proof of concept here, I just threw together a quick LED blinker circuit with this LED Model 2 rate meter. I think I used 2200 ohms as the resistor here, and as you can see it works fine. And just as another example, I got the LED modification working with this other rate meter as well. So in order to calculate the value of the resistor you need to put in series with the LED, you need three variables. You need the voltage of the LED, the current of the LED, and the voltage of the speaker. So if you have these three numbers, you can calculate the resistor you would need to put in series with your LED, and both of those in parallel to the speaker. Now if you don't have an oscilloscope or don't know the voltage at which your speaker is driven at, you could just start from a larger resistance and work your way down until it shines bright enough. Maybe start around 2000 and work your way down. If it's too bright, or if you think it's too bright, then increase the resistance. If it's still not shining, or if it's shining really dimly, then decrease the resistance. And the resistance doesn't have to be completely perfect either. You can usually get away with like 10 to 15% above or below the calculated value. And this is just a quick schematic of the modification. So just an LED in series with a resistor parallel to the speaker.